Assalamualaikum warahmatullahi wabarakatuh. My name is IRFAN and today my group will be explaining our project report for Introduction to Mechanical Engineering. My group mates are HADRI, FATIH, AIZAAC and NIZAM will elaborate the problem statement, the brainstorming process of the problem using mind maps, and explain the two designs we came up with to succeed in this project. Let's take a look at the problem statement first. We were instructed to design a new cylindrical water tank with a 10 to 20% volume compared to the previous tanks. As for reference of the tank's dimensions, the height is 16 meters while the radius is 7. The design must not exceed 0.3 meters more or less from the original height, and radius must be adjusted to meet volume and weight requirements. The total weight of the tanks, which includes the water stored, must be between 30 to 40 kilonewtons. Other than that, we must also analyze the load distribution of the supporting beam for stability and functionality. All must be done according to the CDIO framework, focusing only on the conceive and design phases.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMAD HADRI bin HASHMI and my metric number is 2312377. So today, I'm going to talk about our mind map from our brainstorming session for this project. First of all, we go to the requirements. What is the meaning of requirements? What the new water tank, in order to build the new water tank, what it is required for us to build it. So we need to increase the volume for about 10% to 20% more larger than the previous tank, and adjust the radius for the volume increment, and also maintain the height in 16 meter plus minus 0.3 meter. So that is the requirements. Next one, you go to the design consideration. What we need to consider. So the first one is we need to consider it to be in a cylindrical shape. Material selection is also we need to consider. That's mean we need to choose the best material that is suitable for durability and load capacity. The third one is the calculations. So in order to build a new water tank, we need to calculate, of course. So how and what formula we need to use to build the water tank. So to calculate the volume tank, we need to use the formula pi r square h. The next one is weight range. The new weight range is about 30 kilonewton to 40 kilonewton with water. The second last one is implementation challenge. Of course, in order to build anything or anything in this world, everything have its own challenge. So what is the challenge in building the new design and construction of new water tank? The first one is real-time monitoring the water capacity. The next one is stability and foundation support, and also assembly and maintaining access. Last but not least is CDIO framework. What is CDIO framework phase? CDIO is stand for conceive design. So what is conceive? Conceive is define requirements and initial concept, while design is draft tank design, calculate load and dimensions. So that is all from me for our mind map, and all the 6 main point I have said before is our consideration in order to design and construct the new water tank. Thank you. The last one we need to calculate is the structural stability of base and beam load distribution. That is all about the calculations.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is NIZAM and my metric number is 231113. So next, I will present about the water tank design. So as we know that our problem statement that we need to design the new water tank, which is we increase the initial volume to 10 to 20% of its initial volume, but without changing the height. So this is our calculation to find the dimension of the new R, the new volume itself. So this is this is our calculation. So the initial R is 7 meter and the initial height is 16.3 meter. So how we want to find the initial volume? By plug into the volume of cylinder, which is volume equal to pi r square times with h. So we substitute the initial volume of R, we substitute the initial volume of H, and then we will get the initial volume, which is 2509.2 meter cube. So as we know that we want to design the water tank but increase the volume by 20%. So the formula to find the new volume, which is new volume equal to initial volume times with 1 plus 0.2, which means it's 20% of the initial volume. And then we will get the new volume, which is 3011.04 meter cube. So from that we get the new volume, we get the height, because the height is not changed. So we can find the new radius, which is we plug in back to the formula, and then we will get the new radius, which is 7.6689 meter. So we compare it to the MATLAB code. So this is our coding. We substitute the initial value of R, substitute the initial value of H, and then we substitute the volume or the formula of volume of cylinder. We substitute the formula of the new volume, and also substitute the formula of new radius. So from the MATLAB we get the same answer with our calculation. So to conclude that the calculation that we made are same with the MATLAB code, the MATLAB coding answer that have been given to us. That's all for me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is EZZHAM PUTRA bin AZRULADELY and my metric number is 2318889. Okay, so behind me there is a slide that I will explain to you about the weight distribution for supporting beam. So in this diagram, there is a beam that have a length 15.31362 meter and have two separation at A, AX and AY, and at B, BY, and have 30 kilonewton downward force. Okay, so by applying the engineering statics knowledge, by starting to calculate the horizontal force, we sum up the horizontal force FA equal to 0. So we got the AX equal to 0 because the horizontal force only have at separation A. So next we calculate the moment force. The moment force formula is force times length. So we sum up the moment force equal to 0. The calculation is 30 times 7.6681 meter minus AY times 15.31362 meter equal to 0. We got the AY equal to 15.0222 kilonewton. So at separation A, the horizontal force is AX equal to 0 and vertical force AY is 15.022 kilonewton. So we calculate the vertical force upward positive equal to 0. We sum up the vertical force. So we got AY plus BY minus 30 equal to 0, and we substitute the AY we got from the moment force calculation and equation. So we got 15.022 plus BY minus 30 equal to 0, and we got the BY equal to 14.978 kilonewton for the vertical force at separation B. Okay, next we have to calculate the workload that have distributed uniformly along the beam, across the beam. So the workload formula is W equal to V rho G. So V stands for volume, and rho equal to density, and G is gravitational acceleration. Okay, so the equation is W equal to, we substitute the new volume that we have calculated before from the previous calculation. So we got 3011.04 meter cube, and the gravitational acceleration is 9.81 meter per second square, and the density is 1 kilogram per meter cube. So we got the workload is equal to 29.5 kilonewton, and we rounded to the 30 kilonewton. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is FATIHUDDIN bin RAHIM, and I will present about the third question of the project, which is plot the shear force diagram and bending moment diagram using the MATLAB coding. Okay, so in this slide, first of all, we need to find the length and workload so that we can fill in the shear force equation and bending force equation. After that, we can plot the graph diagram. Okay, so first of all, we need to find the length. So the new radius that we got from the previous equation or the previous slides, we got the new radius, which is 7.6681. We will times by 2, so we got the new length. Okay, so after that, the workload, which is the weight that we will use, we got this information, which is 30 kilonewton. We got this information based also on the previous slide equation. Okay, so the range we use in the diagram after this, which is x equal to 0, 0.1, and L, which is 0 is representative for the minimum value of the diagram, 0.1 which representative by the scale of the x-axis, and length is the maximum value of the diagram. Okay, so this is the shear force equation and also bending force equation, which is the shear force equation is equal to weight times x plus the weight times length divided by 2, and bending moment force is equal to negative weight times x square divided by 2 plus weight times length times x divided by 2. So this both equation we will use in the MATLAB coding to find the both diagram of the shear force and bending force. Okay, so we move to the MATLAB coding. Okay, so as we know, we got all the information in the previous equation. So we got the weight equal to 30 kilonewton, and the length is equal to 7.6681 times by 2. So the x here, as I said before, which is representative of the axis on the diagram. So the V and M here representative of the shear force diagram, shear force equation, and also the bending moment equation. M representative of the bending force moment equation. Okay, so we will plot the XV equation for the first equation, which is for the shear force. We plot the X and V. The shear force act as the y-axis, and the X act as the x-axis. Okay, so the X label we plot by the XM, which is in meter, and also the Y label we plot by shear force, which is in kilonewton. The title for the first diagram we plot as the shear force diagram. Okay, so then we go to the second diagram, which is we plot the X and M, which is M is representative of the bending force equations. Okay, X as y-axis. Okay, so the first equation, the first X label we label by XM in meter, and Y label we type by bending moment kilonewton per meter. So the title of the second diagram, which is the second graph, is bending moment diagram. Okay, so after all this type, we can run this MATLAB coding, and we will got the graph on the screen in the next slide. Okay, after we run the MATLAB coding before, so the shear force diagram and also the bending moment diagram will appear on our screen. So as we can see on the slide, there is the title shear force diagram there, and also as the x-axis there is a x in meter, and also at the y-axis there is shear force in kilonewton. So the straight line here shows that the relationship of the shear force acting on the beam is actually a linear one. Okay, for the second graph we got is actually the bending moment diagram. So the title is there, bending moment diagram, and the x-axis, which is x in meter, same as before, and also the y-axis is actually bending moment kilonewton meter. So this curve is actually shows that the relationship of the graph is actually parabolic. Okay, that's all from me. Thank you.